Hello, I'm Aaron Park, and this is 7th grade, lesson 24. So for number 1, our word problem states that Bart wants to buy at least 50 fruit snacks for the Valentine's treats. One fruit snack pack contains 6 pieces. Write an inequality for the least number of fruit snacks Bart will need to buy. So I'm guessing this means packs of fruit snacks that he'll need to buy. And he wants at least 50. If you look at our answer choices, you'll notice that they're all inequalities, which is good because that's what we want. And now we simply eliminate. You'll note that for 2 of these, we have 50 as our coefficient, and for 2 of these, we have 6 as a coefficient. It will be one of the 6 ones because x is the number of fruit snacks that we want to buy, and each one contains 6 pieces. This means that 6 times x, so 6 pieces per fruit snack, must be greater than or equal to 50 total. You can piece this together by looking at the problem. He wants at least 50. So he wants 50 or 51 or 52, so 50 or more, which is why we have this greater than or equal to. Knowing that, the only answer left is the last one. 6x is greater than or equal to 50. Now we solve for x in the inequality below and mark the correct answer. When solving inequalities and expressions, you want to isolate the variable. So to do that, we first subtract the constant, 0.1, from both sides. This cancels out, and on the right side, we get 2.8. So it will look like this. Then we divide the coefficient off, because if you remember, a number over a number is always 1. Same thing here, where 1.4 over 1.4 is equal to 1. It cancels out, so to say. And on the right side, 2.8 divided by 1.4 is of course 2, leaving us with x is less than 2. Now, mainland traveling basketball teams have 5 players. There are 37 beds in a motel. Write the inequality for the greatest number of basketball teams that can be settled in the motel. So you want the maximum, but you have to make sure that there aren't players without a bed. So on one side we'll have 37, and on the other side we'll have x representing teams. Now we need a coefficient for our x, and it will be the other number in the problem, 5, because there are 5 players per every team, and each player needs a bed. So now the only trick left is to find out whether it's less than or equal to, or less than or greater than, and both of them will be their equal to versions. Now in this case, we want it like this. We want the number of teams times their players to be less than or equal to the 37 beds total. Logically, this makes sense. Our 37 beds must be at least enough for the 5x, the players. If it was the other way around, then that means I could bring in 100 teams for x, and then this side becomes 500, which is the inequality. 500 is greater than or equal to 37, but that doesn't make any sense. Sure, I have 500 players, but only 37 beds. This isn't right. It should not be right. So, if I try to do the same over here, 500 players is way too big. Way too big. It is not less than or equal to 37, so that would cross out. That would be bad, which is good for us. That is the inequality we want. Oops, not this one. This is the 37x. It should be this one. So, our next problem How many football teams can be created of 50 players if each team is 11 players? And we can't have a team with too little players, so we have to make full teams. So the answer is 4, just looking at it. And the reason why is one way you can solve this is by subtracting 11 multiple times. So 11, or alternatively, it might even be easier to multiply 11 several times or add it together, because we have one team and 11 players, two teams 22, three teams 33, we're still under our 50 limit, four teams 44, five teams 55, 55, we only have 50, and we can't just make 5 people appear out of nowhere, so this is impossible. The max is 4. This is similar to problems we already did, so we'll instead go down and look at these inequality problems. Let's try the last one, presumably one of the harder ones. You'll note that the s is on both sides, so we have a bit of work to do. First things first, we'll use the distributive property of multiplication to get rid of these parentheses. This turns into 3s minus 12, and the right side turns into 2s minus 6. Remember, the distributive property says that when we see a parentheses and a number outside like this, we can multiply every term inside by the number outside and get rid of the parentheses. 3 times s is 3s, 3 times 4 is 12, keep the sign, and the same for the right side. Now, we want s on only one side of the inequality, so we subtract 2s from both sides, which leaves us s minus 12 is greater than or equal to negative 6. Then we add 12 to both sides, which leaves us with s is greater than or equal to 6. That is our final answer. Now, I'll leave the rest for you to do on your own. Thank you.